We're starting section 4 today, which is going to be an extension on what we've already worked through. Okay? We've already talked through how to graph polynomials like f of x. The difference being that in this section, they're not going to tell us a factor. They're not going to tell us a zero. We're going to have to figure those out for ourselves. Okay? So whenever we are going about graphing these things, the first thing we've always needed to do is find the zeros or the factors. Okay, if we know those zeros, then we know where the function is crossing the x-axis. We can talk about their multiplicity to describe how they cross or how they touch at the x-axis. We can look at the lead coefficient and the degree to determine the end behavior. We've already gone over all of that. The difference is that this section they won't give us one. Okay? So what we're going to have to do is we're going to have to, and this is not exactly the best thing in the world, we're going to have to guess and check to try out different ways to do it. We're going to have to guess and check. Okay? We're going to have to guess and check. And that sounds terrible on the surface, but it's not that bad because there's a rule that allows us to figure out what numbers to try, what numbers to guess. That rule is shown here in the box called the Integer Root Theorem. Pretty simply put, no matter how big and how ugly the function is, and here it is written in generic form, ax to the n plus blah, 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 all the way down. Any zeros, any place where it crosses exactly on an integer, must be a factor of the constant term. Must be a constant of whatever that, or a factor of whatever that constant term is. Okay? We need to keep in mind that those numbers could be positive factors or negative factors. Okay? We need to keep that in mind. It could be positive or negative. Okay? So, example 1 on your notes says, please list all the possible integer zeros for the following polynomials. This is a relatively simple thing to do. First we say, what is the constant term in letter A? -8. Okay. So if -8 is the constant term, we would simply list the factors of 8. So what are the factors of 8? Okay, 1 and 8. So plus or minus 1 would both be factors. Plus or minus 8 would both be factors. What's the other factor pair of 8? 2 and 4. So plus or minus 2, plus or minus 4. Our integer zero rule says those are the 8 possible integer zeros of f of x. So if we were guessing and checking, we would want to guess those 8 numbers first. Okay? Starting with the smallest ones and working our way to the biggest ones is the way I would suggest approaching it. Okay? So on the second one, what is the constant term in letter B? 6. So we ask ourselves, what are the factors of 6? Okay, because those would be the possible integer zeros of this function. So you've got 1 and 6, yeah, and 2 and 3. And again, could be positive or negative, but those 8 numbers, and it is a coincidence that there are 8 again, okay, those 8 integers are factors of 6, so they might be zeros of this function. Okay? Pause the video, try the third one, then resume the video. So on letter C, the constant term is 20, which means our answers are going to be the factors of 20. That would be 1, 20, 2, 10, 4, and 5. Those would be the possible zeros of this function, the possible integer zeros of this function. Now don't get this rule confused with what we did in Algebra 2, where we had our P and our Q, and we did the P over Q list and then tested all those zeros. That's similar, but that's the rational zero theorem. This is for integer zeros. So it's actually a little bit easier to deal with than the way we approached it in Algebra 2. So on the next one it says factor the polynomial completely, but notice it doesn't give us a factor. We don't know how to factor cubics. I mean, in theory, we might be able to get away with factoring it by grouping, but just looking at it, I can tell you it doesn't factor by grouping very nicely. Because there's no pattern to the four terms. There's nothing I can factor out of the first two and the second two that would result in the same binomial. So we're going to have to use this zero factor rule. Okay? And the way we do that is we ask ourselves, what are the factors of our constant term? So the constant term is 8. Which means we're going to try 1, 2, 4, and 8. And we're basically going to guess and check from that list until we find one that works. And when I say guess and check, I'm referring to synthetic division. Okay? I'm going to take, we should always try 1 and -1 first, because those are the smallest ones. And don't forget to try both the positive and the negative values of those smallest factors. Okay? Positive and negative values. So we take that 1, put it in the box. Coefficients from g of x go outside the box. That's 3, -7, -22, +8. And we run synthetic division. What are we looking for when we run synthetic division? For a remainder of 0. If we get a remainder of 0, then we found a root. Yeah? So bring that 3 down. 1 times 3 is 3. Add down is -4. 1 times -4 is -4. Add down is -26. Is this going to work? No, it is not. That's -18. That did not work. So then we put -1 in the box, and we do it again. We're trying to find one that works. We're going to keep doing this until we find one that works. Okay? 3 comes down. That would be -3, which would be -10. That would be 10, which would be -12. That would be 12. Still did not work. Okay, so that didn't work either. So now we move on. The 1s didn't work. What's the next smallest number in our list? 2. So we put 2 in the box and we run it again. We only need to find 1 because this is a cubic. Once we find one of them, what's left will be a quadratic and it'll probably factor. Okay, so it's got to keep running it until we find one. So 3 times 2 is 6. That's -1. 2 times -1 is -2. That's -24. That one is not going to work either. So 2 didn't work. Means we move on to -2. We're going to keep trying until we find one, which I'm betting this one will work. So 3 comes down. 3 times -2 is -6. Add down is -13. 2 times -13 is 26. Add down is +4. -2 times 4. There we go. We found one that works. There's the one that works. -2 works. Now what that means is that f of x is x plus 2, because -2 is in the box. Yeah? So x minus -2 is x plus 2 times 3x squared minus 13x plus 4. These three numbers tell us the rest of it, right? So 3x squared minus 13x plus 4. So we're using synthetic division to factor. Okay? Now I look at that and I can tell you right now that at most one more of these zeros is going to be an integer. The other is going to have to be a fraction, because that's advanced factoring. But I can also tell you that 3 times 4 is 12. Numbers that multiply to 12 and add to negative 13, they exist, so this does factor. Okay? So we need to factor this trinomial. Those numbers would be negative 12 and negative 1. So we break up that middle term into negative 12 and negative 1. Group. And factor the greatest common factor out of each of those. So that first set of parentheses, I can factor out a 3x. So 3x times x minus 4. The second set of parentheses, I can't take anything out, and to make it match, I need to factor out a negative 1, which would give me x minus 4, meaning that that factors into x minus 4 and 3x minus 1. I bring this factor down and put it in front, and that is f of x in its factored form, x plus 2 times x minus 4 times 3x minus 1. So on letter B, we'd start off by making a list of possible zeros. Again, we're looking at the 9 to do that. Means we're looking at only 6 options for possible integer zeros, 1, 3, and 9, positive and negative. So we're going to put one of those numbers in the box, starting with 1. I always do 1 first, but that's just me. Then I do negative 1 first every time. Don't forget to put a 0 in between the 4 and the negative 12. If you don't include that 0, synthetic division does not work, so you cannot trust your answer. We're running this, so 1 comes down, 1 times 1 is 1, add down is 5, 1 times 5 is 5, add down is still 5, 1 times 5 is 5, add down is negative 7. That did not work. So then we try negative 1. Again, 1, 4, 0, negative 12, negative 9. 9, not 19. This one I think does work. Looking at it, 4 plus negative 1 is 3. 3 times negative 1 is negative 3. Add down is negative 3. 1 times negative 3 is 3. Add down is negative 9. Yep, that works. Okay, now that sort of helps, but it doesn't help a lot, does it? Because that gives us that f of x factors into x plus 1, because negative 1 is in the box, so x minus negative 1 is x plus 1. Well, then we're left with x cubed plus 3x squared minus 3x minus 9. Now that can be factored by grouping. Okay, if we take that polynomial x cubed plus 3x squared and we group the first 2 terms and the second 2 terms, we can factor a GCF out of the first 2 and out of the second 2. The first 2, we can factor out x squared, leaving x plus 3. The second 2, we can factor out negative 3, leaving x plus 3, which means the 2 factors are x plus 3 and x squared minus 3, meaning that the factored form of f of x, because neither one of those will factor again, would be x plus 1 times x plus 3 times x squared minus 3. Now, x squared minus 3 does not factor again because 3 is not a perfect square, which means it does not match difference of 2 perfect squares. That means our roots for this function would be negative 1, negative 3, and then plus or minus the square root of 3. So that does it for B. So that is as far as we're going to get in class today. We will finish this lesson tomorrow, and the assignment will officially be assigned tomorrow, meaning it'll be due on Thursday.